Welcome back to the part 2 of the previous video that we have done till grouped queries. Now let's start with the second part, that is your having clause. Now suppose your principal says I only want those students where the highest marks are above 90. Can we use where? Many students immediately answers yes, but the answer is no. Let's understand why. Where filter rows before grouping, having filters groups after grouping. That's the biggest difference. Let's write the query over here. Before writing the query, you have to use here let me increase the size, use your database name, that is your college, and run. After this, let's write the query for the having clause. Like first of all, you have to write down here select city, comma, aggregate function, that is your maximum of marks from where? From table, that is your student. Then group by according to city, then having marks, or you can say having maximum marks is greater than 90. Then execute. Now SQL first creates city-wise groups, then it calculates the highest marks. Finally, it removes those groups where maximum marks are less than or equal to 90. This is why having always works after group by. So let's take another example. Let's count student city-wise, but only display cities having more than 2 students. So write down select city, comma, count star from student group by city, having count star is greater than 2, semicolon, and run. Only cities satisfying the condition remains. Remember this interview trick. Where works on rows, having works on groups. This single sentence will help you answer many SQL interviews question. So let's see the general order execution. Now here's something very interesting. When we write a query, we usually write select whatever you want to select the column, then from table name, then where condition, after this group by according to which column you want to group by, then having, what will be the condition over here using aggregate functions, then order by, in which order you want the output, in ascending or descending, and in the end is your limit, how many rows you want to see in the output. Then in the end, semicolon, and run. But SQL does not execute it in that same order. Internally, SQL processes the queries in this sequence from where, let me write over here, from, after this where, then group by, then having, then select, then order by, and in the end limit. Let's understand it with a simple explanation. First, SQL decides which table to read. Then it filters rows using where clause. After that, it creates groups. Next, it applies the having condition to those groups. Then it selects the columns requested. Finally, it sorts the result using order by. Knowing this execution order helps us understand why certain queries works and other don't. Now let's learn how to modify existing records. Let's see, firstly see the table over here. Select star from student, then execute. Suppose Rahul's marks were entered incorrectly. Instead of 89, they should be 93. Do we delete the record? No, we simply update it. The syntax is like this: update table name, then set column name is equals to its value, then where you want to update, where, then condition. This is the simple order how you can update the value instead of 89. So let's take the example over here. Let's execute in the query. Update student, then set marks is equals to 93, where ID is equals to 1. Run. You can see the output is over here, that is executed. Now let's see. Now verify the changes. Select star from student, student, student. You can see here the marks are now updated with 93. Everything else remains the same. So updating multiple columns, how you can perform the updating multiple columns? Suppose we also want to update Rahul's city, then you have to use like this: update student set city is equals to Chandigarh, comma, marks is equals to 94, where ID is equals to 1. That's so simple. Then run. Again, run this command to verify the changes. You can see city is also changed over here and marks is also changed over here. So SQL allows us to update multiple columns in a single query. A very important thing. Now watch this carefully. Let's see. Update student set marks is equals to 100. There is no where clause. What happens? SQL updates every single record. Every student now has 100 marks. This is one of the most common mistakes beginners make. Always check your where clause before running an update query, especially in production databases. Now let's learn how to remove records. Suppose Rohit leaves the college, this one at the ID 5, Rohit leaves the college. We don't need his record anymore. Instead of updating it, we delete it. So the syntax for deleting the record: delete from table name where condition, CONDI condition, like this, then semicolon. So in this way you can delete the values. So let's execute it. Delete from student where ID is equals to 5, then semicolon, and run the query. Let me show the table again. Again, select star from student, then run. You can see the ID 5 is deleted over here. That's exactly how delete works. So another important warning. What if I write like this: delete from student, student. Without a where clause, what will happen? Every row in the table will be deleted. The table structure will remain, but all the data will disappear. So before pressing the execute button, always double check your where clause. One wrong query can erase thousands of records in a real database. So excellent everyone. If you have followed the lecture till this point, congratulations. You know how to retrieve data, filter records, perform calculations, update information, and delete records. But in real world projects, we usually don't work with just one table. We often have multiple related tables. For example, imagine a college management system One table stores student details, another table stores course details, a third table stores fees information. All these tables are connected to each other. Now imagine we delete a student from the student table. What should happen to that student's course details? Should they remain? Should they be deleted automatically? That's exactly what we will learn now. Let's first understand the problem. Suppose we have two tables. First one is your parent table, that is your students. Select star from students and semicolon and run. You can see student ID and name is over here. 101 Rahul, 102 is Priya. This is your parent table. Now second one is your select star from course, semicolon and run. This is your child table with course ID, student ID and course. Course ID is 1, 2, 3, student ID 101 and 102. Courses are Python, SQL and Java. Notice that the course table refers to the student table using a foreign key. Now imagine we execute this statement, delete from students where student ID is equals to 101. Now execute. Now let's see what happened with this. Select star from students, run. What is that 101 ID? That is your Rahul. But what about the course table? It still contains Python, SQL for student 101. So let's see, select star from course. Now see, now the database has inconsistent data because those course records point to a student who no longer exists. This is called an orphan record. To solve this problem, SQL provides on-delete cascade. When a parent row is deleted, all matching child rows are automatically deleted as well. So if Rahul is removed from the student table, his course records are removed automatically too. You don't need to delete them manually. This keeps the database clean and maintains referential integrity. Now let's look at another situation. Suppose Rahul's student ID changes from 101 to 201. If the child table still contains student ID 101, the relationship breaks. To avoid this issue, we use onUpdate cascade. Whenever the primary key changes in the parent table, SQL automatically updates the matching foreign key values in the child table. So if 101 is changing with the 201, the child table is also updated automatically. No manual changes are required. That's the purpose of onUpdate cascade. Whenever you design databases with related tables, this cascade option helps keep the data consistent. Now let's move on to another very useful command. Suppose you have already created a table. After a few days, your manager says, we forgot to store students' email addresses. Do we delete the table and create it again? Absolutely not. Instead, we modify the existing table. For that, SQL provides the alter table commands. Alter table allows us to change the table structure after it has been created. So let's start with the alter table commands. First one is your add columns. Let's add an email column. Alter table. What's the table name? Student. Then add column. I have to add email column over here. Email. Its data type. Varchar. Its constant value. I am writing here constant value as 100. Then semicolon and execute it. Now check the table structure. Is the structure is updated or not? Select star from student, then semicolon and execute. Now see over here, a new column named email has been added. No existing records are deleted. Only the table structure changes. This is one of the most common alter operations. Now suppose we created the age column as integer. We have created the age column as integer. Later we decided to change its data type. For that we use modify over here. So how you can modify? alter table name is your student, then modify age as big int. I am changing its data type from integer to big int, then run. Now you can see the data type changes successfully. Notice that the column name remains the same, only its data type or constants are modified. If you want to check, then use the describe function over here. Describe table name student and run. You can see what's the data type of age, that is your big int. So let's go to the next topic. Now suppose your manager says don't use the column name, use student name instead. Instead of deleting the column and creating a new one, we rename it. So how can you rename? Alter table name student, change column name with which column? Student name, its data type varchar and its constant value, that is 50, then semicolon and run. Now if you want to check, then again select star from student and semicolon and run. You can see the name is changed with the student name. One important thing to remember, with change column you must specify the data type as well. Many beginners forget this and get syntax error. Now suppose the email column is no longer required. Instead of keeping unnecessary columns, we remove them. So how you can remove the column? Alter table student drop column, that is your email, semicolon and run. Again execute the select star from student. You can see the email column disappears completely. Remember, once a column is dropped, the data stored in the column is also removed. So use this command carefully. Now imagine your company changes its naming convention. Instead of student, they want students. Now you don't need to create a new table. Simply rename it. If I want to rename the table from student to something new like student data or something else, you can rename it simply. So how can you rename it? Alter table student. Now rename to with which I am renaming the student as student data, and semicolon and run. Now you can see, let me refresh the schemas. Inside the tables you can see the student data is over here. Now let's understand the next concept. Now let's understand one command that many beginners confuse with delete. That command is truncate. Suppose you want to remove all rows from a table but keep the table itself. You can use truncate table, truncate T-R-U-N-C-A-T, truncate table, its table name, that is your student underscore data, then semicolon. Now run. Next, let me show you the table. Select star from student data, semicolon and run. The table still exists, the column still exists, but every record has been removed. Let's quickly compare these three commands, which are delete, truncate and drop, because they are frequently asked in interviews. So let's understand the delete first. What delete performs? Remove selected rows, can use a where clause, table structure remains. So how can delete perform? So first of all, delete from table name, that is student data. I am writing here where id is equals to 1, like this, then run. Now here it will just remove that row with id 1 from the data. So next is your truncate. Truncate removes all the rows. where clause is not allowed, table structure remains faster than delete when clearing an entire table. Next is your drop. Drop removes the entire table, data is cleaned, table structure is deleted, the table itself no longer exists. Whenever you are deciding between these commands, ask yourself, do I want to remove a few rows? Use delete. Do I want to empty the table but keep it? Use truncate. Do I want to remove the table completely? Use drop. These distinctions are fundamental when managing database objects. So before we end today's lecture, here is a small challenge for you. Pause the video and try these queries on your own. Here, these are 10 queries over here. If you can complete these tasks without looking at the notes, you have understood today's lecture very well. Let's quickly recap everything we covered in these videos. Where clause, comparison operators, and or not, between, in, limit, order by, aggregate functions, group by, having, SQL query execution order, update, delete, on delete cascade, on update cascade, alter table, add column, modify column, change column, drop column, rename table, truncate table. So congratulations to all. You now have a solid understanding of how to retrieve, analyze, update and modify data and table structure in MySQL. And that's a wrap for the today's session. This was one of the most important lecture in our SQL series because these are the commands you will use in almost every SQL projects and technical interviews. In the next lecture, we will start one of the most exciting topic in SQL, that is your join. You will learn how to combine data from multiple tables using inner join, left join, right join, full join and self join. These concepts are essential for real-world database development and interview preparation. If you found this lecture helpful, like the video, comment which SQL topic you found most interesting, share this video with your friends and classmates, subscribe to the channel and turn on notifications so you don't miss the next lecture. Thank you so much for watching. I am your instructor from Banshai and I will see you in the next class. Happy learning.
Don't forget to like, share and subscribe for more content.